Hi, I'm Paquera12 and today we play with the unit vector and we build something very similar with what we have here. And you might think of what's the connection between this and unit vector, and you can find a lot of information on this on internet, and I will try to give myself one explanation. And let's imagine this is a vector pointing into this direction, right? And now, what if I replace this vector with another one showing the same direction but having a different length? Now, in terms of directions, they are similar, right? And for having easy computation between them, we use a unit length for both, so they both of them become one unit length like this, right? And one advantage of having a normalized vector like this is no matter what the direction, the tip of the vector will always stay on a sphere. So yeah, let's see this here. We will build this file with those clouds, spherical clouds floating around. And let's see if we go for a lot less points. Let's, for example, say 2 by 2. Okay. Now here we have 4 points. They are very, very small there. Okay. But I want to see some vectors. And so I have this tool here. Okay. And now I have a vector from center 0 to each point. Okay. And yeah, let's build this. I leave this here to guide me if I do something wrong. And yeah, let's start clean here and delete the default file. Okay, and now let's grab noise stop. Okay, and we go for 1 pixel for the moment. Okay, and we need this to be 32 RGB, sorry, and not monochrome. Okay, now we have a point, and we chain a null here, and this is yeah, 1 pixel. Okay, and I can have 1 point also in chops. So here I have 3 coordinates on x, y, z. I can have this as tx, ty, tz, and so is the same thing. Or I can have this in dots. So I have a table, okay, with the coordinates. Or I can have this in 3D like this. So now the point is somewhere inside there. Here is the point. Okay, this is the same as I would go with add, and with this I add 1 point, so I have 1 point here, and instead of having these coordinates I can grab those. So now I have the same point in a 3D space. Okay, and let's take off the viewer for this. Okay, now what I want to do is to have a little sphere where I have this point. So let's use a select top and grab this point here. Okay, and okay, let's use a null. Okay, and a sphere which would be a lot smaller. okay, like 0.02 maybe. Okay, let's see. Okay, and I use geometry. Okay, and I'll take this texture here. I'm using experimental version, so it's much easier to instance many points. Okay, let's split the screen now because I want to have a look at my geo. Okay, and yeah, the point it's here. Yeah, say 0.02. Okay, like this. So now I would like to have a line from center 0 to that point, and you can have this I don't know if here I use group. Okay, there are many ways of seeing those lines. Okay, and I'll take pixel here and offset with -1 and take here 0. Now I have 2 points. The first one it's 0. The second one it's our point. Okay, and I go with chops from here. I don't need alpha. Okay, and let's see now in subs. So I need to say here RGB. Okay, now I have a line which goes very nice in place. Okay, but actually I want to have a real geometry, not a line, and so I need to use a tube like this, and then I need to rotate on each axis, right, to match this point. Okay, and yeah, let's have that. Okay, so I will leave this here, and I'll take the select. Okay, Control C, Control V. Okay, now here I would like to have a folder where to compute the rotations that I need. So I use a null here. Okay, and let's have this collapse selected, and so yeah, let's go inside, and from here what I would like is to have this into a chop. Okay, and I'll go with tx, ty, tz. Okay, and I don't need alpha for now, and now I need to use object chop, which is very nice operator, and for the second input it says reference, and I would like to have a reference as center 0, so let's have a constant here. Okay, and I have tx, ty, tz. No, sorry, it's 0 here, and ty and tz. Okay, and yeah, we go like, oh sorry, we go like this. Okay, and now here I need to take the bearing out. Okay, and I go with the output. Okay, like this, and here I also want to output what I got, but instead of going with RGB, what if I use alpha channel for taking the length of my vector? So let's use a mod here. Okay, and this one, with this one, since I have 3 values, right, RGB, and the length of the vector is either you go with Pythagora, so you have here square add root, or you pick up length right here, you need to mask alpha channel and take the 32 mono, and now we have the length. Okay, and here we use a reorder. Okay, and I'll take second input for the alpha, but I'll take red out of here. Okay, and this has to be 32 RGBA. Okay, like this. We good. And yeah, let's work a little bit more parametric. So what if here instead I have not only one pixel, I'll have, let's say, 2 by 2. Okay, so I go here and say 2 by 2. Okay, now we need to make some little changes, right? So here we go with top 2, we take tx, ty, tz, but from full image, and here we need to shuffle. Okay, so we shuffle by channels name. Okay, and this has to have the same length, so I can take an info here. Okay, and yeah, let's take this, and I want to have the length. Okay, so this would be okay, this goes here and -1. Okay, now it's the same length. Okay, and also here I would like to have the same, so I'll take this and use it as -1. Okay, let's see. Now I want to use this texture here for let's take for all of those nearest pixels. Okay, okay. I have my points here, also my length, and here I have my rotations needed for all the vectors, right? So now to build a vector, we use a tube. Okay, so we have here something like tube, I believe. Yeah. Okay, now we go with let's go with 2 rows and 16 columns, and I'll need this to be on x-axis, and yeah, the radius should be very, very small, and let's go with 0.02 also. Okay, and I need a geometry here. Okay, and I would like to have the starting point in the center, so I would offset this by height. Okay, divided by 2, and now we good. And we have here in the geo as many instances as the channel we use has samples in it. So let's use this, right, to rotate, and we take Rx, Ry, Rz, and it's wrong. Okay, so let's see. First of all, we have 4. Okay, we wrong here, so the length is not 2. Let's take the length of either we length of this and we multiply with itself, or we take this shuffle. Okay, much better. Now we have the correct amount of tubes, and the rotation is not good, since here in the object we need to specify the bearing reference, and so we need to find out the angles for this tube, as I start with it in 0, 0, 0, and it stays on x-axis. This is the bearing reference, okay? So this should be x here. So now we good. What we need here in the jaw, we also use this texture for scaling, and we only take A. Okay, now my vectors has the right length, but I would also want to use something for the tip, and the tip goes right here, and it has a specific length. So the length of the tube should be minus the length of the tip, right? So how we do this? Okay, let's see. So let's take this here, and first let's build a tip. Okay, we are using the again a tube, and let's make it on x-axis. Here we go the same with 2 and 16. Okay, and now the second radius has to be 0. Okay, the center has to be where is height divided by 2, I believe, with -1. Let's see. Yeah, minus. So I need the tip here. Okay, and now obviously the first radius is too big, so let's go with 0.325 maybe. Yeah, and for the height here I would go with 0.1. I don't know. Okay, now we change this. Okay, let's use the height also here for the radius, and I would say divided by 3. Yeah, it can be good like this. Let's see. And also I need a geometry here. Okay, and here I'll take this texture. Let's set the instancing on, and I'll take this texture. Okay, so I have R, G, and B. Okay, now my tips are staying good. What I need to rotate them. Okay, and actually I need the same values. Okay, so I'll take this for rotation. Okay, and now we need to decrease the length of the tube. Okay, and we do that by using a mat here. Okay, and this mat should only bring changes on alpha where I have the length. Okay, so for that I want to mask everything else, and let's go for nearest pixels also, and here I would like to have the value, and post I would add minus this. Okay, so I'll grab it, okay, here, and I put minus. Okay, and now, yeah, I don't necessarily need those spheres, and I have some vectors now. Let's make these tubes a little bit thinner, right? Okay, like this, and yeah, just make this moving a little bit. So ABS time dot seconds divided by 20. okay, and now, oh, 20. Now they are moving, and you notice they are the points are placed in between 0, 1 or on each axis, so it might be useful to use a mat here and rearrange these from 0 to 1. Let's first set the nearest pixels. Okay, so from 0, 1 we rearrange it from 0.5 to 0.5. Okay, now, yeah, they are spread even all around the center. Okay, and remember what I said with unit vector. Now the length, it's changing value. Okay, and let's see how we get the unit vector by normalizing those vectors, right? So let's use a null here. Okay, since maybe you need to normalize some other values, and so you have a component here, and we collapse selected, and let's say normalize. Okay, and inside what we need to do is we use a mat. Okay, and here we can go with Pythagora and have square add root, or we just take length, and we need to mask alpha channel to not be taken in the formula. We don't need it. And here we need 32 mono. And now we have here 4 values, which are the 4 lengths of those vectors. And now we need the composite here, and we divide the xyz coordinates of those vectors, okay, with this length by doing this. So first let's take divide, and fixed there would be input 1. Okay, and now look what happened with my vectors. They stay the same length. Okay, and let's bring here inside a sphere. Okay, just to see it. So I need a material. Let's use a material, because I want to take a little transparent material for this. So okay, and yeah, let's set the alpha 0.1. Let's see it, and here I go with this. Okay, so now all the tips are staying on this sphere, and let's see if I go crazy, as maybe I want 1000 vectors. So yeah, we have 1000 vectors, which surprisingly looks like Dandelion. Okay, and yeah, if we go much higher here, let's say, I don't know, 128 by 128, yeah, you lose some FPS, but yeah, this is not the point. So we don't need as many arrows, since we can't see them anyway. So yeah, let's go down a little bit by 32. Okay, and but now what if we use the knowledge here and try to manipulate those points, and we might not need to see the vectors. Okay, so yeah, let's let's stop, take off the vectors, okay, and also the spheres, the sphere, right? And now let's see the points. Okay, now I have a bunch of points walking on a sphere, and now I can go much higher if I want to, okay? And yeah, since the sphere is mesh, okay, I'll have some drops, or yeah, maybe there are too many, who knows. Okay, let's see. Yeah, obviously there are way too many now. And 64, let's go. Okay, let me check a little bit, because yeah. So I will close the viewer, so I will pass by this. Okay, now I believe we can go on 1 to 8 and 1 to 8, and we find, yeah, the slowing part was this job, which having the viewer open was causing the drops, okay. And I believe we can go higher with ease, right? And yeah, we have 60 fps. Now, what if I don't want to instance geometry, since yeah, one sphere has 42 points already? So what if I use naked points, just one point? Okay, so let's have that. So remember, with add, okay, we just add a point, and now we need to convert this, okay, into point, and yeah, let's use this, and we need a special material, point sprite material, okay, here, and it's much better now, right? And we can go crazy with this, so let's say 1024 by 1024. So now we have more than 1 million, right? And yeah, let's use some colors, right? So I'll have these points. What else I need? Maybe if I yeah, if I use a noise, so I use a noise, okay, and I'll take this point position, and let's have this 32 RGB, and color, and yeah, maybe 16, I don't know, we'll see later. So 0 0.2, 0 0.2, 0 0.2. Okay, so now we use a null, okay, and we'll take these colors here in an instance 2 tab. Okay, now we go for R, G, and B, and I get some error here since I don't have the same resolution. Yeah, it's not the same resolution. So what I would like, let me check. So I have the same here, and yeah, so I will take this resolution here, okay, okay, and this one goes here. Okay, now we have our points, and yeah, you can play with those values. And now let's make something else. Okay, so now what if I want to pixelate this? So let's bring in a pixelate component. Okay, so okay. You see, now I have a bunch of flies, maybe, right? But I would like to form a couple of other spheres. Okay, so I'll go here and let's see how big we are. Okay, and if I increase here horizontal and vertical pixel size, I'll get some very nice sphere clouds, and I can noise them now. Okay, like this, and I go here with offset 0, amplitude 0 for the moment, not monochrome, and 32 RGB. Okay, so now if I play with this amplitude, I can change the shapes, and they looking like jellyfishes or something, right? And yeah, this was my tutorial on unit vector, and yeah, you should know with this little trick you normalize a vector, and so you can get some nice curve surface. And yeah, I really hope you like this, and subscribe if you haven't yet. Hit the like button, or you can support me on Patreon, where I'll have much more tutorials, since I do one there for every tutorial I release here. So let me show you a little bit of what I had this morning. It's a 49 minutes tutorial with custom point clouds. Here you might want to check. Okay, and I want to thank to all my patrons, and special thanks goes to Ocean Snolar, Roy Gerritsen, Gavin Grindon, and Dimitri Diak. And thank you so much, and see you in the next one. Bye.